going. I'm gonna click on over here. All right, I think we're good. So, any questions, you guys? Anything y'all want to go over? Let me make sure that my pen is working. Here we go. All right. Any questions from the homework y'all want to go over? Anything? Go ahead. All right, so I heard 9x squared. Excuse me. Plus 18x minus 27. That's it? Equals 0. Like that. So to do this, right? The first thing I would do is I would look for a GCF, right? So greatest common factor right here, I think, is 9, right? So I'd factor 9 out. Remember when you factor out 9, it's like you're dividing by 9, like you're dividing by 9, like you're dividing by 9, right? So what am I left with? X squared plus 2x minus, what's that, 3, right? Yeah. That's equal to 0. Yeah. It's easy, right? Yeah, that's it. So now, after you do this, which method are we doing with this? Are we completing the square? Are we quadratic formula? Completing the square? All right, cool. So to complete the square with this, right? I'm gonna ignore the 9, right? I'm gonna ignore the 9. So I'm just kind of just gonna work. I'm kind of just gonna work with the inside, and I'm gonna bring the 9 back at the end, right? So on the inside, I have x squared plus 2x minus 3 is equal to 0, right? So the first thing I want to do is I want to isolate my constant term, right? So I'm going to add 3 over here to get rid of it. Or what I do to one side of the equation, I have to do to the other side of the equation, right? So now I have x squared plus 2x is equal to 3, right? Next, what I want to do, I want to go straight to my formula, right? And my formula is negative b over 2a squared, right? So I'm just going to plug it in, right? In this question right here, I have negative of 2 divided by 2 times 1 squared. That's going to simplify down to what? Negative 1 squared. I'm just doing a little quick because of space, right? It's equal to 1. So I'm going to add 1 to both sides of this equation, just like that, right? Now, simplifying this further now, right? The x squared plus 2x plus 1, I want to factor that. So tell me what that's going to be. And that's 4. So we know that this is going to be x, right? What's the sign going to be? Is it going to be plus or minus? Plus, very good. And then what's the number that's going to go here? Not 3x, 1, right? It's going to be 1, all right? So now, right, is this one of those AHK questions? Okay, so they're just looking for the answer. All right, so whenever they're looking for the answer now, I could completely ignore the 9 now. I don't even need 9 no more, all right? What I'm gonna do, and by the way, that's a 1, all right? What I'm gonna do is just solve for x. So I'm gonna square root this side, but what I do to one side, I gotta do to the other. So now when I do it to this side, I'm left with what? X plus 1 is equal to, and then remember, when you do the square root for the number, there's gonna be 2 signs, plus or minus, and square root of 4 is 2. After that, I'm gonna subtract 1 from over here, and what I do to one side, I do to the other, right? So now I have that x is equal to negative 1 plus or minus 2. There's 2 answers there though, right? So we have x1 is going to be negative 1 minus 2. Let's call that negative 3. And x2 is gonna be -1 plus 2. Let's call that +1. And that's it. Yeah. Go ahead. Oh, yeah, yeah. Wait, give me 1 second. This is completing the square. This particular question. Yeah. So it's solving a quadratic. Yeah, or solving quadratic equations. Huh? Or the formula? Use whichever one you want. Yeah. But for your homework, you're gonna see that some of the questions on the homework like kind of force you to use completing the square, you know? But for the next homework, it's kind of like whatever you want. That's the 9.2 I'm talking about. So 9.2, you kind of have to do this, right? When you, for like half of the homework, the part that says like what's A, what's H, what's K, you have to do this formula. But to give me the answer, whatever you want. If you want to factor it and give me the answer, fine. If you want to do this to give me the answer, fine. If you want to use a quadratic formula, give me the answer, that's fine too. No, it doesn't. This works for everything. Completing the square and the quadratic formula works for everything. Factoring only works for like when it's factorable. Sometimes you don't have a number that adds up to the middle and multiplies to the end, so you can't factor it. But you can always use this. Always, always. Or you can use the quadratic formula. All right. Are we good? Okay, welcome. All right, your turn. Mm-hmm.
3 minus 5i.
Mm-hmm. Mm-hmm.
Minus
Mm-hmm.
6.
All right, so for this question, right? What you want to do, you want to distribute the negative, right? So now what do I have? I have 3 minus 5i minus 6 plus 6i, right? And then you just combine like terms, right? So real numbers are real numbers. Imaginary numbers are imaginary numbers. So 3 minus 6 is what? Close. What is it?
3i. 3 minus 6.
Mhm.
Oh, negative.
-3, right? And then negative 5i plus 6i is what?
Negative 5.
Mhm.
11.
Not 11. Negative 5 plus 6.
Oh,
Not -1. 1i, right? So plus I, right? Yeah, because like you owe me $5, but you give me 6. You know, so yeah, right. Mhm. And that's it. Mhm. It's combined like terms. Mhm.
It's not foil.
Not FOIL, just the negative. If it was next to each other, like say it was something like this, 3 minus 5i times 6 minus 6i, right? You see how there's nothing in between them? That's FOIL.
Yeah, I was just confused. That's
Yeah.
almost exactly like that.
Yeah. Nah, that's just straight up addition or subtraction.
I
Yeah.
have one exactly like this, but it was
Yeah.
addition sign.
In between,
And
yeah.
I just
So
had to combine those.
yeah, you just drop the parentheses and add the real numbers with the real numbers and the complex with the complex. Or imaginary, whatever.
Well,
Sure.
you just distribute the 5 or the
For
negative?
which one you talking about?
Distribute the negative sign. Then.
Yeah, just change the signs to everything to the right, and then just add. So 3 plus -6, -3, and -5i plus 6i is 1i.
Okay, so
Yeah.
you don't even really distribute, just distribute negative and
Yeah.
take away the parentheses.
Yeah. Mhm. Any other questions? All right, go ahead. X squared minus 8x minus 12 equals 0. All right. And what do we do? Quadratic formula? All right. So for the quadratic formula, right? First thing I got to do is I got to identify A, B, and C, right? So what's A? 1, good. And what's B? Close. What's B? -8, right? And then what's C? -12, right? And then after that, you just plug it straight into the formula, right? Well, actually, what we know, we got to also make sure that this is in standard form. I should have said that earlier, my bad. You should have verified that first, but it already is in standard form, so I didn't say anything. Anyway, after we figure out what A, B, and C is, go straight to the quadratic formula. I have X is equal to -B plus or minus the square root of B squared minus 4AC all divided by 2A. All right. Just change my color up real quick. So after that, I'm just going to plug it in the formula. So this is negative of -8 plus or minus the square root of -8 squared minus 4 times 1 times -12 all divided by 2 times A, which is 1. And after that, just do the math on it. Nothing crazy. So negative times a negative is a positive. That's 8 plus or minus square root. I have 64. A negative times a negative is a positive, and 4 times 12, I think, is 48. Divided by, I think, 2, right? Because 2 times 1 is 2. And then you want to add these together. This is the hard part. So 8 plus or minus square root. Oh, Lord, what's this? I got 64 plus 48. Don't judge me. I have no idea what this is.
You find the square root of 64, then square root of 48.
No. First you add them, then you can do that. 7, 112, right? Yep. So 112 divided by 2. And I'm not gonna lie to you, I have no idea how to do this. So what I gotta do, I gotta break this down. I'm looking for the largest perfect square that goes into 112. And I don't know what it is. So I'm just gonna cut it in half. Half of 112 is like, I think, what, 56? And I'm gonna cut this in half again. That's what, 25, 26, 27, 28. I'm gonna just cut this in half again. That's 14. And I already know half of 14 is just 2 and 7. So boom, boom. All right. So I have 1, 2, 3, 4 2s and 1 7, right? 4 2s and 1 7. Right? So 2 to the 4th power is what again? I don't even know. You see, 2 times 2 is 4, 4 times 2, 8, 8 times 2 is 16, right? So I can write this as 8 plus or minus square root 16 times 7, right? And the square root, whoops, I didn't see that. And the square root of 16 is what? 4, right? So this is 8 plus or minus 4 square root 7 over 2, right? Now I can reduce this a little bit further. I'm just gonna break this apart so you can see how I do the reduction. So this is gonna be like 8 over 2 plus or minus 4 square root 7 over 2. So 2 goes into 2 once, 2 goes into 8, what, 4 times? 2 goes into 2 once, 2 goes into 4 2 times. So my final answer for this is just simply 4 plus or minus 2 square root 7. And that's it. All right. If you want to separate them, be my guest. If you're doing it for web work, you're gonna have to probably separate it. Yeah. How you separate it? So look, x1 would be 4 minus 2 square root 7, and x2 would be 4 plus 2 square root 7. And you just put them in, right? The 4 minus 2 square root 7, that's the small one. And the 4 plus 2 square root 7, that's the big one. You know? In case they ask you, like, yeah, yeah. That helps me to differentiate, you know, that I have two different answers here going on. Yeah.
Alright, so
Mhm.
what did you do after the square root of 4 square root 7? Put it in the
Oh,
fraction.
I broke it apart so that you could see that like 2 is gonna divide the 8 and the 4. Because I wanted to reduce it down to 4 plus or minus 2 square root 7.
What's being divided on the right side? 4.
So 8 divided by 2 is just 4. And then 4 divided by 2 is just 2. And the square root 7 just stays there because you can't really do nothing with that.
So isn't it 6? 4 plus or minus 6?
No. We can't combine them because that square root 7 is like being multiplied times a 2. So it's not like a true 4 plus 2.
Okay.
Yeah. But I'm sure in your calculator it would do something like that and give you some decimal answer. 1 second. That's it. You don't need this part. Yeah, just that. And that's it.
Okay.
Yeah, so like number, comma, number.
Oh, so the extra wasn't.
Yeah.
So the 4 square root of 7 is divided by 2, that gives me
Mhm.
this answer.
It does?
No. It'd be 2 square root of 7. Right.
Okay.
So like if you're, want to get the 7, just use calculator.
Go ahead. Yeah. Mhm. Yeah.
Divided by
Mhm.
4 is 4 divided by 2 plus 4.
Let me see if I can blow it one time. See. Nah, I gotta do it down to 40. All right, that's the whole question right there. Hmm? Good. Got it? So this is the one before it. It was the I part or the completing the square one you wanted to see?
Yeah.
That's it. All right. Hmm?
Wouldn't be taking that 28.5 twice? That's crazy.
Yeah. The topics are the same, so
So many more concepts.
yeah. They build on it a little bit. Go ahead. Get that? That's it? And then, so we just want to solve for it? What? So, all right, AHK. So, first thing I want to do, right? Make sure standard form, which it is. I'm gonna set this equal to 0. So 0 is equal to 2x squared minus 9x. All right. Now I have a problem with this question, right? My a term here is not 1. So when I'm doing completing the square, I need my a term to be 1. So to make this 1, I'm gonna divide by 2. But not just the first term, everybody's gonna get divided by 2. Right? So now what do I have left? I have 0 is equal to, these canceled out, x squared minus 9 over 2x. right? Now that I have it in this form, I can complete the square, right? So to complete the square, I'm gonna go straight to my formula. My formula is negative b over 2a squared, right? Now, in this case, I have negative times negative 9 over 2 divided by 2 times 1 squared, right? And let's do the math on that. This is going to become what? 9 over 2 times 1 over 2 and then squared, right? The reason why it's 1 over 2, remember the denominator here is like 2 over 1, keep, change, flip, all that good stuff, right? So now I should have 9 over 4 squared, which is going to become what? 81 over, I was about to write 4, 16, right? Because we're squaring them. Now, 81 over 16, you're going to add that to both sides of your equation. So plus 81 over 16 plus 81 over 16, right? So now on my next line, I have 81 over 16 is equal to, and I want to factor this, right? So we all know that there's going to be an x right here. What's the sign going to be, plus or minus? Minus, very good. And we know it's minus because my b term here is negative, so that's going to make that negative. And what number am I going to write up here? Say it again. Perfect, 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 right? Always just carry this over, right? Make our life easy. 9 over 4. Boom. All right. So, go back to here, right? So I have 81 over 16 is equal to x minus 9 over 4 squared, right? Now you remember earlier on in this question, right? I divided by 2, right? So what I want to do now, I want to bring that 2 back. So I'm going to multiply this side by 2 over 1. And what I do to one side, you know, I got to do to the other. So multiply this side by 2, right? So when I'm multiplying the 81 over 16 times 2, I'm going to reduce that just a little bit. Let me see. 2 goes into 2 ones. 2 goes into 16, I think 8 times. So this is going to give me 81 over 8 is equal to 2 times x minus 9 over 4 squared. And then final step, I want to subtract this 81 over 8 to get it on the other side. But what I do to one side, I got to do to the other. So my final answer is 0 is equal to 2 times x minus 9 over 4 squared minus 81 over 8, right? Now here's the thing, right? For the homework, you know they have that AHK thing, right? So the formula that you're going to write it in is y is equal to a times x minus h squared plus k. That being said, tell me what's the answers. What's A? Okay, and what's B? 9 over 4. And then what's C? Very good. That's it. I brought it back because remember, remember in the beginning when I divided by the 2 up here? So just to make it concrete, bring it back to the answer, I brought 2 back. So I just multiplied both sides by 2. That's all. Yeah. That's it. So in a nutshell, that's how you complete the square, so to speak. Mm-hmm. Yeah. 1 minus 3i, 2 plus I.
So 6 plus complex fraction.
Standard form. All right. So it's illegal for me to have i's in my denominator. So I'm gonna have to multiply this by the conjugate. So what's the conjugate of this? Right, that's good. Now what I do to the bottom, I do to the top. And after that, just distribute, combine like terms. Sorry about that. Yeah, just distribute and combine like terms, right? So that's like 1 times 2 is 2. I heard that. 1 times negative I. Negative 3i times 2 is negative 6i. Negative 3i times negative I is positive 3i squared. All divided by 2 times 2, 4, minus, what's that, 2i plus 2i minus I squared, right? Now we remember I squared is what? Right? So I'm gonna change this up. So I have 2 minus I minus 6i plus 3 times negative 1 all over 4 minus 2i plus 2i minus negative 1, right? Let's do our multiplications now. So I should have 2 minus I minus 6i minus 3 over 4 minus 2i plus 2i. A negative times negative is positive 1. All right. Well, no, now what we want to do, we want to combine like terms, right? So 2 plus negative 3, yep, that's negative 1. Negative I plus negative 6i is what? Negative 7i. Let's do the bottom. Negative 2i plus positive 2i cancels out. What's 4 plus 1? 5. And that's it. That's the answer.
So just the conjugate.
Yeah. Conjugate. Question? There you go. All right. So let's jump into today's lesson. This is a fun day and a sad day. No more algebra. We're moving on, bigger and better things. And this is gonna be like really, really easy too. What's up? No? We're 5. Yeah. That's it. All right, so this is what we're getting into now, right? We're gonna be talking about right triangles, all right? Right triangles. So here, in this picture, we have a right triangle, right? And I'm just gonna introduce it to you. So everybody knows that a triangle has 3 sides, all that good stuff, right? A right triangle, right, has a 90-degree angle in one of the corners, so to speak, right? And right, we're gonna solve for t, right? So in this example, we're calling the inside angle here t. This is one of the other angles that are there. All the angles inside the triangle add up to 180 degrees, right? But what I'm interested in is what is this particular angle t, right? Which is in the picture. From t, right? The opposite side, right, is right in front of it, right? So if t is here, the opposite side is going this way. That's opposite, right in front of you. It's opposite, right? Adjacent, right? Adjacent means next to, right? That's the definition of adjacent, next to. So whenever I say, what is the adjacent side of an angle? I'm asking you which leg is next to the angle, right? Adjacent means next to, opposite, straight across, right? And always, always remember this. Always remember this. I'm gonna get a blue marker for this one, right? The longest side of the triangle is the hypotenuse, right? Longest side of the triangle is the hypotenuse. Opposite the 90-degree angle is the hypotenuse, right? This is the hypotenuse, all right? The slanted side is the hypotenuse. Remember that. Really, 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 really important, all right? So any questions on this so far? Right? This is a right triangle, right? So what we're going to be doing is we're going to be using, we're going to be making ratios, fractions, from these triangles, right? So first, let's talk about the ratios that we're going to do. We have 3 trigonometric identities. We have sine, cosine, and tangent, right? Sine is the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. And tangent is the opposite side divided by the adjacent, right? Now, I'll be honest with you, from day to day, I don't remember this, right? So what I do to remember this, right, there's an acronym that I use. It's called SO, right, SOA. That's the acronym that I use to remember this, right? So for SO, sine is opposite over hypotenuse. For cosine, cosine is adjacent over hypotenuse. For tangent, tan is opposite over adjacent, right? This is what I use to remember it, right? So anyway, common mnemonic, remembering these relationships is SOHCAHTOA, formed from the first letter of sine, which is S, is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. Any questions on this? Make sense? Promise this is a lot easier than you might think it is. All right. Not feeling it? All right. I got you. I got you. Let's do it one more time. Let's do it one more time. Right? I know I like to repeat myself, right? So here's a little how-to, right? So given the side lengths of a right triangle and one of the acute angles, those are the little baby angles right there, right? Find the sine, cosine, and tangent of that angle. So step 1, to find the sine, right, as a ratio of the opposite side to the hypotenuse. To find the cosine is the ratio of the adjacent side to the hypotenuse. To find the tangent as a ratio of the opposite side to the adjacent side. All right. Let's get complicated. I'm joking. This is real simple right here. All right. Now this is a little simple. It's just asking for cosine, but I'm gonna make this a little bit harder. All right. I'm not even gonna pay attention to that, right? I want to know what is cosine of alpha. That's what this little symbol here is alpha, right? Those of you that want to pledge like fraternities and sororities, you know, like there you go. That's alpha right there, right? Yeah. Kamala Harris, you know, she's a Alpha Kappa Alpha. That's where it comes from, right? Yeah. So that's sine. I mean, excuse me, that's cosine. I want to know what sine of alpha is. And then lastly, I want to know what tan of alpha is, right? Put some equal signs over here. So somebody tell me, what do you think cosine of alpha is? Adjacent over hypotenuse, right? So we got the SOHCAHTOA right here. So I heard that 15 over what?
Oh no, hypotenuse.
Right, 15 over 17. That's it. That's the answer. Right? So right here, that's my adjacent, ADJ. And then remember that this is the hypotenuse, right? Always. That's the hypotenuse. Right? Mm-hmm. It is opposite. Very good. So what is sine? You can use SOHCAHTOA. Go ahead. What's the answer for sine of alpha? Very good. All right, this one's gonna be real hard, right? Once again, this alpha right here. What's tan alpha? Very good. And that's it. That's the whole thing of trigonometry. Enjoy. Yeah. That's all it is. All right. Any questions on it?
Class is done.
Oh, no. There's more. Yeah.
The exam tomorrow.
Yeah.
That's great.
Tomorrow Thursday, right? Yeah.
It's gonna be like this, or we're gonna get harder.
Nah, there's more to it than this.
Oh,
Yeah. Yeah. We building up to physics. Your favorite class. Yeah. What you mean?
Physics, algebra, trigonometry, all back to back.
Physics is the best. What you
No, that
mean?
was high school. Oh.
Uh-huh. Make it smaller? I got you.
Think my schedule wanted me to hate life.
No, this was it. Yeah, the previous was an example. But you guys try. Probably should be giving y'all a test question early, but whatever. You guys try. Oh wait, don't pay attention to that. I want all of them. I want sine. I want cosine. Why I keep saying alpha? See that last question just got me.
They don't label it like adjacent.
Nah, they don't. That's the thing.
But I can see the hypotenuse in the top part.
Just know that whatever reference angle they have, like this is T right here, that's where you're gonna look from, you know?
So adjacent is what? Opposite?
No, remember adjacent is next to,
So
right? And opposite is away from you.
across.
Yeah.
So adjacent is 20.
Yeah.
Okay.
Yeah.
And opposite is 7, hypotenuse is 25.
Yeah.
Okay.
So then just answer these real quick. You can use SOHCAHTOA. SOHCAHTOA. What's up? Or you got an umbrella? For real?
No, it's 20.
Okay. Whew. Got scared there for a second. I'm like, oh, man. Damn. Dang, when do you sleep, man? When do you sleep? Oh man.
What is this again? Sin is the
Sin is the opposite of a blessing. You didn't get it.
Wait, what?
When you said what is sin, that's just the opposite of a blessing.
I was trying.
So
SOH is.
so sine is opposite over hypotenuse.
Opposite of hypotenuse.
Mhm. So what I'm looking for like a ratio here. I'm looking for some fractions. You want to try it, Jay? So we doing trig now.
It is like.
So I'm looking at the angle right here. No. That's a triangle. Oh, not the triangle. That's the squares. Yeah. So you want to try it? Yeah. Say it again. Good. Good. Very good. That's it. Easy, right? Yeah.
No, wait, the opposite for hypotenuse, so.
What do you mean? For sine?
Yeah, so
Yeah.
it's 24 over 25 instead of 25.
Or for cosine or for sine? Which one?
Side.
So for sine, it's opposite over hypotenuse. So opposite the angle T would be the 7. And then the hypotenuse, you already know, is always slanted side. So it's 7 over 25. For cosine, right? Remember, cosine is adjacent over hypotenuse. Adjacent means next to. Right? So that's just the 24 over the 25. Mm-hmm. And then tan is just opposite over adjacent, right? Opposite over adjacent. And that's it. And if you get like a really big one, you don't got to reduce it for me. You could just leave it the way it is and show. More. Yeah, there's more. So, of course, you know, this is like a textbook example, right? That's not real life. So let's look at real life, right? Nah, it's good. It's good. Right? So here we go. This is real life right here. So we're relating angles and their functions. So when working with right triangles, the same rules apply regardless of the orientation of the triangle. In fact, we can evaluate the 6 trigonometric functions. Oh yeah, there's 3 more. I didn't tell y'all that. Right? Of either of the 2 acute angles in the triangle. So the side opposite to one acute angle is the side adjacent to the other acute angle, vice versa. All right, let's talk about this real quick. All right. So I have this right triangle right here, right? You see, here goes the right angle right up here. Let me get some rainbow for this now, right? Now, depending on which angle you're talking about, right? You're gonna have either an opposite or adjacent leg being given to it. But for all of them, this is the hypotenuse, right? That doesn't change. The hypotenuse is always the same, it doesn't change, right? Now, let's say, for example, I'm talking about angle alpha. So alpha is right there, right? Lower left-hand corner, right? Next to alpha, next to it, adjacent to alpha, would be this leg right here, right? That's going to be the adjacent alpha. Not really. You just have to know which one is, yeah. Yeah. And across would be opposite, right? And this would be the opposite to alpha, right? That's if I'm talking about that angle. But let's say same triangle, but I want to talk about the other acute angle, right? That B right there, that's called beta, right? So this is beta, like BETA, beta. Yeah, like the fish, right? So, yeah, so now look, if I'm doing beta now, right? Let me get orange for this now, right? I'm doing beta, right? Opposite from the beta angle would be over here, right? Straight across. Opposite is always straight across. Let me just label that real quick, right? Adjacent to beta would be this one, ADJ. Right, whatever's next to it, right? So the leg that's next to the angle is adjacent. The leg that's across from it is the opposite, right? And once you know that, the rest of the questions I'm going to ask are easy. What's sine, what's cosine, what's tan, whatever, right? But I did say that there were 6, right? So we'll be asked to find all 6 trigonometric functions for a given angle in a triangle. Our strategy is to find the sine, cosine, and tangent of the angles first. Then we can find the other trigonometric functions easily because we know that the reciprocal of sine is cosecant, and the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent, right? Let's take a look. Let's take a look. This is about to be fun right here.
Okay,
Mm-hmm.
basically it's.
Huh? You know?
We find
Mm-hmm.
the,
The sine, cosine, tangent.
yeah, for
Yeah.
A.
Mhm.
use a, numbers. Put that beta.
Yes, you
From
can.
opposite.
That's true too. Yeah, that's true. Mm-hmm.
Because they could be the opposite.
Mm-hmm.
of
The
beta.
flip of it. Yeah. Mm-hmm. So let's take a look at this real quick, right? Give you a little bit of notes before we jump into it. So, given the side lengths of a right triangle, right, we want to evaluate the 6 trigonometric functions of one of the acute angles. If needed, draw the right triangle and label the angles provided. Sometimes they'll ask you questions where they don't even give you the angles. They'll just be like, yo, angle A is this and side A is that. Boom. You know, but I'm gonna show you how to deal with that. I'm gonna show you how to deal with that. Yeah, that's what I'm gonna answer. Yeah. But I got you. I got you. It's light. I promise
So we
you.
got,
Yeah.
is it at least gonna give us the hypothesis?
I'll give you that. I'll give you that. Yeah. So if needed, right, draw the right triangle and label the angles provided. Step 2, identify the angle, the adjacent side, the opposite sides of the angle, and the hypotenuse of the right triangle. And 3, find the required function. So here they are. This is all 6 of them, right? So sine as a ratio of the opposite side to the hypotenuse, cosine as a ratio of the adjacent side to the hypotenuse, tangent as a ratio of the opposite side to the adjacent side, secant as a ratio of the hypotenuse to the adjacent side, cosecant as a ratio of the hypotenuse to the opposite side, and cotangent as a ratio to the adjacent side of the adjacent side, to the opposite side. Right? For real? I got you, man. I'm gonna make it mad simple. Don't worry, I got you. Yeah. I got you, huh? I'm gonna give you something. You're gonna see. So look at this real quick, right? Real simple triangle. 3, 4, 5. Right? How we gonna find all 6 of them? Right? But you know what? Let's make life even more fun, right? Let's find beta as well. Right? Mm-hmm. Not beta itself. We're gonna find the functions with it, right? So I'm gonna start off with, hold on. I'm gonna start off with alpha, right? We're gonna do alpha in pink, right? So for alpha, I want sine of alpha. I want cosine of alpha. I want tan of alpha, right? But also, right, I want cosecant of alpha. I want secant of alpha. I want cotan of alpha, right? I want all of that, right? So here's where all of this comes from, right? I'm gonna show y'all the trick. I'm gonna show y'all the source right now, right? So ka toa, right? Yeah, this is light. This is light. So for the sign of alpha, what sign of alpha? I'm just doing some different colors real quick. 4/5, right? So opposite to alpha is the 4 over the hypotenuse, which is the 5, right? So 4/5. That's excellent. What about cosine? What's that? Cosine of alpha. 3/5, right? That's going to be the adjacent over the hypotenuse, right? 3/5, right? So this is the adjacent right here. All right, what about the tangent? That's the hard one. What's the tangent? No, 4/3, right? Opposite over adjacent, right? This is the opposite, and this is the adjacent. Right? All right, cool. Let's take it up a notch now, right? What's cosecant? Right? Cosecant. So here's how I do cosecant, right? Cosecant, write this in pink, right? Cosecant is just 1 over sine alpha. And what was sine alpha? We did it already. 4/5, right? So this is just 1 over 4/5. And then y'all remember, right? Keep, change, flip. So you already know that's 1 times 5/4. Call that 5/4. That's it, right? Cosecant, what's excuse me, secant, right? What's secant? Secant is 1 over cosine of alpha, which is just simply 1/3/5. And y'all already know, right? Keep, change, flip, right? So what is that? 5/3. Cotangent is the easy one right here. Cotangent is just 1/tan alpha, right? And that was what? That was 1/4/3, right? So what we gonna do? Keep, change, flip. This is 1 times, what's that? 3/4. So this becomes what? 3/4. That's it. Light work, right? So now,
Our part is finding the first part, remembering all.
got you. But now here's another question you probably gonna say, but on the test, like, how am I gonna remember that cosecant is 1/sine and not 1/cosine and all of that, right? So this is a really, really deep mathematical concept right here, right? I'm gonna write it down. Y'all should write this in your notes, right? Always remember in life, there's one co and no coco. All right. Yeah, one co, no coco, right? So cosecant can't be 1/cosine because that's coco, right? Every single one of these pairs has one co. Sine, cosecant, cosine, secant, tan, cotan. There's one co, no coco. Remember that. All right.
Lost me. I would have just said. Thing as.
Yeah. Tan and tan, yeah. I don't know. I always do one co, no coco. So let's say that I wanted to know what cosecant is, right? Like, how do I remember that cosecant is 1/sine and not 1/cosine? If it was 1/cosine, that's coco, right? So every one of these pairs all have one co, no coco, right? So you see sine, cosecant, you see cosine, secant, you see tan, cotangent, right? One co, no coco. So that's how I remember that.
You have a great mouth for close.
Huh?
You have a great mouth plus.
I have one more test to grade and I'm straight. I could, but later on. Later on.
Yeah.
So what I'm looking at when I say that, I'm looking horizontally, right? Horizontally. So I'm saying that sine relates to cosecant as 1/sine, not 1/cosine, right? If it was cosecant equal to 1/cosine, that's coco. There's no coco. Every pair, horizontally speaking, has one co. So sine, cosecant, cosine, secant, tan, cotangent. Okay.
Yeah.
Yeah, y'all will get it with some practice. I promise. All right, real quick. Let's take it up a notch, right? So help me out. I want sine of beta. I want cosine of beta. I want tan of beta. Whatever those equal. And then I want cosecant of beta. I want secant of beta. And I want cotangent of beta. I want all of those. Right? This our little triangle right here. Let's just go one by one. Looking at this triangle real quick. What's sine of beta? Say it again. Very good. All right, so I got 3/5 right here. What is cosine of beta? Say again.
Beta.
Beta. No. 4/5. That's it, right? So remember, I'm using this angle right here now, the orange one, right? So this is the adjacent, and then this one is the opposite now. You see, when you switch angles, the side switches. Yeah, yeah, yeah. So go ahead. 5 is the hypotenuse. Yeah, yeah. So what is tan of beta? That's next. 3/4. Very good, very good. All right. That's true, right? So remember, cosecant is 1/sine. Let's say beta right here.
Yeah.
No, I'm doing it so that you can see it. So this becomes 1/3/5. And you already know, keep, change, flip, all that good stuff. So 5/3. For secant of beta, you know that this is going to be 1/cosine of beta, which is equal to 1/4/5. And you already know, keep, change, flip. That's going to be 5/4. For cotangent of beta, that's going to be 1/tan of beta, which is equal to 1/3/4. You already know, keep, change, flip. That's 4/3. And that's it. So questions on this? How you guys feel about that?
Radiation code.
The codes?
Yeah.
The codes might be the. It's all about the cocoa. So that being said, you guys try. Because of time, I'll just leave it at T. But you guys get the idea, right? Between doing both angles.
We're doing the beta now.
Nah, just do the T. Just this one. Because of time. So.
we do,
Mhm.
send house.
Mhm. All of them, okay. Sine, cosine, tangent, secant, cosecant, cotangent. Yeah, just all six of those. You don't have to do all 12, just those six. All right, sorry about that pause. I was giving y'all last homework for the rest of the semester. That's it.
Last over?
Hmm? Last. Huh? No, not yet. That's next week. All right, so now I have this triangle right here, right? I'm using angle T right here, right? Help me out. What sign of T? All right. 33 over 65. Very good. What is cosine? All right. 56 over 65. What's tan? 33 over 56. Good. What is secant? Yeah. Over 56, yeah. And then what is cosecant? 65 over 33, very good. And cotangent? 56 over 33. Go ahead. Yeah. I scrambled it, I know. I didn't have space, that's why. But yeah. I was doing that so y'all understand where it's coming from, you know? Yeah. Mm-hmm. The secant? Remember, secant is 1 over cosine. So it's just the flip of this. And then cosecant is the flip of the sine. So 65 over 33. And cotan is just the flip of the tangent. Yeah. Yeah, that's all it is, just a flip. Yeah.
Question.
Hmm?
What is you?
A lot of things. A lot of things. You in part, what the hell? No, it's a pop-up on my computer. All right. You in particular, you think what you would use this for? If you ever got into like robotics, right? Like you would use this, like in building, like the body and stuff like that. A lot of measuring, like building this room is all this. The pyramids in Egypt, all of that was this.
Nobody know how to build pyramids.
They could build it. Yeah, pyramid is like now it is, but the question is, how did they do it? We could do it now. How did they do it? Yeah, yeah, they did. Yeah, they're the ones that invented this. This was invented in Egypt, all right? And then the Greeks, they went down into Egypt and stole that joint and patented, and here you go. Yeah. Huh? That's what they did with knowledge. You know? Yeah. All right, so let's talk about this now. So we're going to talk about finding trigonometric functions of special angles using side lengths. Yay. Hmm? So we have already discussed the trigonometric functions as they relate to the special angles on the unit circle. We'll get to that. Now we can use those relationships to evaluate triangles that contain those special angles. We do this because we do this when we evaluate the special angles in trigonometric functions. They have relatively friendly values that contain either no or just one square root in the ratio. Therefore, these are the angles often used in math and science problems. We will use multiples of 30, 60, and 45. However, remember that when dealing with right triangles, we are limited to angles between 0 and 90 degrees, right? Suppose we have a 30 degree, 60 degree, 90 degree triangle, right? which can also be described as pi over 6, pi over 3, pi over 2 triangle. The sides have the sides have lengths in the relation s square root of 3s and 2s, right? The sides of a 45, 45, 90-degree triangle, which can also be described, as pi over 4, pi over 4, pi over 2 triangle, have lengths in the relation s square root of 2s. These relations are shown in this figure right here. Excuse me, I got hiccups. Sorry about that. No problem, no problem. All right. So, blah, blah, blah. I'm gonna break it down to y'all real quick, right? If I have a special right triangle like this, right? Where this is a 90-degree angle right here. Let's say that this is 30 degrees right here. That would make this other one be 60 degrees, right? Always remember this. Opposite the 30-degree angle. Opposite the 30-degree angle is 1, right? The hypotenuse is 2, right? And opposite the 60-degree angle is a square root of 3. Always, always, always. So opposite the 30-degree angle is 1, right? Opposite, the hypotenuse is 2, and then opposite the 60-degree angle is a square root of 3. Always, always, always. All right? I got you. Is 1, right? Opposite 30-degree angle is 1. The hypotenuse is 2. And then opposite the 60-degree angle is a square root of 3. Right? I don't know if you could kind of see where I'm going with this. I'm going to ask you questions like, okay, what's like sine of 30 degrees, for example? You know? And then you would just tell me what? What's sine of 30 degrees? 1 over 2, that's it. Right? I might ask you something like, what's cosine of 60 degrees? And what would you tell me? No. I got y'all. Look, Sol Katoa. 1 over 2. Right? This is where I'm going with this. So this is a special right triangle. This is called the 30, 60, 90-degree triangle right here. Right? But I got another one for you. Got another one for you. All right? I'm gonna do this one in purple. Let's say I have another right triangle here where this angle is 90 degrees right here, right? This one is the 45, 45-degree triangle, right? And its side lengths are 1, 1, square root of 2, right? Notice how the angles repeat. So the legs must repeat. 1, 1, square root of 2. And then, as you can imagine, I'm going to ask you questions like, what's tan of 45 degrees? What's that? So does it matter? What's tan of 45? 1, right? Just 1 over 1. That's it, right? I might ask you, what is sine of 45 degrees? What would you tell me? One over what? 1 over the square root of 2. Now, you know it's illegal for me to have radicals in my denominator, right? So what am I supposed to do with that? Multiply it by square root of 2, right? But what I do to the bottom, I do to the top. So the final answer is what? Square root of 2 over just plain 2. That's sine of 45 degrees. So the only thing that you have to remember, you just have to remember these special right triangles. There's only 2, right? There's a 30, 60, 90 degree triangle where you have the legs 1, 2, radical 3. And then you have the 45, 45 degree triangle, which is this one, where the legs are 1, 1, and then the hypotenuse is square root of 2. That's it. No? I can find that. We're gonna go over that. If you want to see, so tan of which one you wanted to look at? Yeah, tan of which angle? 30 or 60? Yeah, it don't matter. You want to do tan of 30? All right, so tan of 30 degrees, all right? Remember, tan is opposite over adjacent, so what is it? Exactly, right? But remember, it's illegal for me to have radicals in my denominator, so I got to multiply by the square root of 3 over the square root of 3. So my final answer is the square root of 3 over 3. That's it. Fun, right? It's the bomb over here. Yeah. That's the 45 right there. Yeah, remember those angles right there. All right. Now we about to get into an example real quick. All right. Actually, before we even jump to that example, I want to talk about something real quick before we jump to that example. So you notice in our reading over here, right? They referred, let me do this in yellow real quick. All right. They referred to the 30, 60, 90 triangle, right? As pi over 6, pi over 3, pi over 2, right? There's a way to go in between these angles, for lack of a better term, right? To go between degrees and radian, right? So I want to show you that. Also, they refer to the 45, 45, 90 degree angle as pi over 4, and pi over 2. So let me just show you that real quick before we jump into the next example. All right? All right, so let's say that I want to go from degrees to radian. From degrees to radian, right? I'm just gonna throw out a number. Let's say I have 30 degrees right here, right? Now I want to change that from 30 degrees into the radian form of it, right? All you have to do is you have to multiply by pi over 180. Matter of fact, let me put that in colors real quick, right? Because that's the sauce right there. Pi over 180, right? No, anytime you have a degree, right, and you want to switch it to radian, this is how you switch it to radian. You multiply by pi over 180. Right. So basically it just becomes 30 pi over 180, and it kind of kill a 0 here. 3 goes into 3 ones, 3 goes into 18. Like how many times? 6, I think. Yeah, if you're gonna do that. That's a good question. I have to Google that one. All right. So that's how to go from degree to radian, right? And we could do it for all of them, right? We could even do it for 60. Say I want to do 60 degrees, right? All I have to multiply by is what? Pi over 180. And Yeah, that's the formula right there, right? How I remember it too is that in radian, the answers have pi's in it, right? All the radians have pi's in it, right? Degrees don't have pi's. They just have that little circle on the top. That's it, right? So if I'm multiplying this straight across, you already know this is gonna become what? 60 pi over 180. Kill a zero, kill a zero. 6 goes into 6 once, 6 goes into 18, I think like what, 3 times? So this becomes pi over 3. That's simple, right? What if it was 90 degrees? Oh, this is hard now. This is hard now. 90 degrees. I'm going to multiply by what? Pi over 180 to get it into radian form, right? So this becomes what? 90 degrees? Well, not 90 degrees. 90 times pi over 180, all right? Kill a zero, right? This is just pi over 2. Simple, right? Awesome. How about 45 degrees? How about 45 degrees? I'm going to multiply this by pi over 180. Multiply straight across, this becomes 45 pi over 180, right? And we just got to simplify that, right? Oh, Lord, how do I simplify that?
45.
What's this? Five goes into 45 how many times? Like 9 times, I think. And then 5 goes into 180 how many times? I don't even know. I'm about to cheat. 36 times, right? And then let's see, 3 goes into 9 3 times, 3 goes into 36, I think 12 times. 3 into 1, and then this is like what, 4? So this is just pi over 4. All right? Y'all could have done that in the calculator. 45 divided by 180 and gotten 1 over 4, and then boom. All right?
You just do the degree sign.
No, not for radian.
Okay.
For radian, all the answers will have a pi in it. All right? Yep. I hope none of y'all copied this down because this is one of your homework questions.
Which one go back up?
Like for real, that's one of your homework questions, no joke. Huh? That's a, all right, so I want to do the reverse now. All right. I'm gonna go from radian now to degrees. All right. Go from radian to degrees. So I'm gonna just steal the first one, pi over 6. I'm gonna steal that one, right? So over here, let me just do this in blue real quick. Over here, I want to go from radian to degrees. So let's say I start off with pi over 6, right? Here's a source right here, right? Remember what I told you, all of the radian measures, right? They have what in them? They have pi's in them, right? All of the radian measures have pi's in them, right? So I want to get rid of the pi, right? So the formula to go from radian to degrees is 180 divided by pi. Right, it's the opposite, it's the flip, right? So think about it like this, right? This is pi in the numerator, pi in the denominator. So what's gonna happen here? You're gonna cancel out, right? That's how you remember it right there. So it becomes 180 over 6. And then 6 goes into 180, how many times? Like 30 times or something? And boom. So that's how you go from radian to degrees, right? You multiply by 180 divided by pi, right? Let's say I had, sure. Yeah. I was gonna say, let's say I had like pi over 4, for example, right? All I gotta do is multiply by the formula, right? I wanna go from radian to degrees, so I'm gonna multiply by 180 over pi. And you already know the pi's are gonna cancel. That's what I want to happen, right? So now I have 180 divided by 4. Let me think about that real quick. Half of 180 is 90, and half of 90 is 45. So there we go, 45 degrees. It's that simple, right? Let's say I had pi over 3. Let's do another one. Let's say I had pi over 3. And I want to transform that from radian to degrees, right? From radian to degrees. I'm going to multiply by the magic formula, 180 over pi. And you already know what's going to happen, right? The pi's are going to cancel, right? So this becomes what? 180 over 3. And I think 3 goes into 18, what? Like 6 times? So let's call that 60 degrees. Just like that.
How many
Hmm?
functions does
I don't know. I didn't make it yet. So let's say we have pi over 2, right? Now I want to go from radian to degrees. Radian to degrees. So I'm going to multiply by the magic formula. This is going to be 180 over pi. You already know what's going to happen, right? Pi is going to cancel. So I have 180 over 2, which is going to become what? 90 degrees. Right? And that's it. That's how you go from radian to degrees. All right. Now, me personally, I like to work all my problems in degrees. Sometimes you might get a question and they might give you a radian number, right? You got to switch it over to degrees and then boom, you'll be able to do it with the triangle and everything. So let's look at this example real quick. Check this out, check this out, check this out. So I'm evaluating trigonometric functions of special angles using side lengths, right? So we want to find the exact value of the trigonometric functions of pi over 3 using the side lengths, right? This might sound crazy, but it's not, right? All you do, switch it from radian to degrees, right? Radian to degrees. And what's that magic formula? I want to get rid of the pi, so the pi is going to be in the denominator. 180 is up top, right? You already know pi's cancel out. So it's going to be what? 180 over 3. Now 3 goes into 180. What's that? 60? 60 degrees? That's it. So as soon as I have the 60 degrees, this problem is done. This problem is done because watch this now, right? I'm going straight to my special right triangle, which we discussed earlier. And the special right triangle does not change. I don't care where you want to put the 60. You want to put the 60 up top, the bottom, it don't matter. Which way you want to put it? Top or bottom? Top up here, all right. So we got the 60 degree right here. That means that this one down here is 30 degrees. Opposite the 30-degree angle, we know is 1. Hypotenuse is 2. Square root is 3, right? Now, instructions say they want us to find the exact values of the trigonometric functions, right? So what are these exact values? Let's talk about this. We're looking for sine of 60 degrees, right? Actually, they really want sine of pi over 3, but we did the conversion, so we know that sine of pi over 3 is actually 60, right? But anyway, sine of 60 degrees, what is that? No. 60 degrees. Where's 60 degrees? Hmm? Oh, my fault. I forgot to write over here. Let me give y'all the sauce real quick. SOHCAHTOA. There you go. All right, so what is it? Exactly, right? Square root of 3 over 2. What is cosine of 60 degrees? What do we think that is? 1/2. Very good. What is tangent of 60 degrees? No. No. Remember, tan is opposite over adjacent. Square root of 3/1. Very good. All right. What about cosecant of 60? What's that? What's cosecant of 60? All right, so I heard 2 over the square root of 3. But remember, it's illegal for me to have radicals in my denominator, so I got to multiply by square root 3 over square root 3. So my final answer is actually 2 square root 3 over 3, right? What about secants of 60 degrees? 2/1, very good. I'll take that. And what is cotangent of 60 degrees? 1 over square root of 3. But you know it's illegal for me to have radicals in my denominator, so I got to multiply by square root 3 over square root 3. It's going to give me what? Square root 3 over 3, right? Rationalize our denominators is what that's called. And that's that. Sure, no
How
problem.
does that work though? I think you can multiply it, right, by a square root.
You can. Yeah, you just put them next to each other.
Also, it would be 1 square root 3 over.
Yeah. What happened? Hold on. Yeah, Microsoft be wilding sometimes. All right, there you go. That's the whole thing. Okay. Would you guys like to try one? No, for real? It's easy, I promise. I'll give y'all the easy one. Check this out. Check this out. Nah, that was the hard one. The only thing I could ask you that would be equal to that is, oh, what's 30 degrees? But y'all could do that. It's the easy one right here. No triangle. Just draw it yourself. Yeah, yeah, draw it yourself. Yeah. You could draw it. Don't worry.
Convert radians to degrees, you have to do 180 over 5, right?
Yeah.
So it's not working.
Do it on paper. So like
just
the
cancel
pies
out
will
the
cancel
pi.
out, then just divide it. Yeah.
Calculate don't be about that.
Because the calculator, I'm gonna say that it does. The calculator evaluates, that's the word I'm looking for, right? So when you put the pi in, it's like multiplying it with decimals and all of that. Like it doesn't do like symbolic math, if that makes sense.
Here.
Yeah, that's it. Just type it in. Yeah, if y'all bored, y'all could like totally knock out your homework
first step. We'll have the second.
I mean, most of the homework's already been done in class, so. Basically, you just reduce the fractions that you find in. That's it. So you got one homework that's converting, the other homework is like this triangle stuff. Fun stuff.
Alright, so we're just calculating when the number that you're plugging in so as a pi.
It does?
Yeah,
Okay.
like for this one, it won't do itself pi simple, so this cancel out nothing.
What is that one?
This is 5 to convert from radians to degrees.
From radians to degrees?
Yeah.
So same thing, you multiply by the 180 over pi.
Yeah, no work for this. This one works as a pi symbol.
So like that one you should have a pi in the denominator with it.
The first one.
Yeah, it sounds crazy, but yeah, there should be a pi in the
Also,
answer with it.
cancel.
Because there's nothing to cancel out in that. That's why. All right, let's take a look at this one, right? So we want to find the exact values of the trigonometric functions of pi over 4. Now, I don't really like the pi over 4, right? So what am I going to do? I'm going to multiply this. I'm going to take the, right, by 180 over pi. Very good, right? Pi's will cancel. You get 45 degrees, right? Bam, right? So now that I have the angle, which is 45 degrees, I can draw the special right triangle right here. Boom. Right? The 90-degree angle will be over here. This is going to be 45, 45. And my sides are what? 1, 1, square root 2. Excellent, right? And then you already know, we're just going to run through it real quick, right? What is sine of 45 degrees? What is that? 1 over square root of 2, good. But you know I'm not allowed to have radicals in my denominator, so I got to rationalize my denominator. Multiply by square root 2, square root 2. Final answer, square root 2 over 2. What is cosine of 45 degrees? One over what? Cosine. Oh, my fault. I didn't write it over here. Hold up. So, okay, what's cosine? Right. So what's the hypotenuse? Oh, what's the hypotenuse? Square root 2, right? So remember, it's illegal for me to have radicals in my denominator, so I want to rationalize my denominator by multiplying by radical 2 over radical 2. So what does this become? Radical 2 over 2. What about tan of 45 degrees? Right? That's 1 over 1, right? Just 1. What is cosecant of 45 degrees? Well, we know that cosecant is 1 over what? 1 over sine of 45 degrees, right? And we know that sine is what? This is 1 over the square root of 2. And what we're going to do, keep, change, flip, right? So this is going to be 1 times square root 2 over 1. So final answer, square root 2. What is secant of 45 degrees? Same thing, right? So it's going to be like 1 over cosine 45, which you already know is 1 over square root of 2. Keep, change, flip. So just square root 2. What is cotangent of 45 degrees? What's that? Just 1. That's it. Flip the 1, becomes 1. Questions on this? Easy?
No.
Gotcha. Huh? Mm-hmm. 180. All of them add up to 180, all three angles. But in the right triangle, since 90 is one of the angles, the other two have to add up to 90. Yeah,
So.
yeah. You'll see that in pre-calc. Yeah, we're not going that deep. That actually would require a calculator, to be honest. Do, 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 do. Huh? Yeah. Yeah. You just deal with the numbers, right? So using trigonometric functions, all right? In previous examples, we evaluated the sine and cosine in triangles where we knew all three sides, but the real power of right triangle trigonometry emerges when we look at triangles in which we know an angle, but do not know all the sides, right? Let's take a look at that. That sounds fun. A little how to. So given a right triangle, the length of one side and the measure of one acute angle, you can find the remaining sides. For each side, select the trigonometric function that has the unknown side as either the numerator or the denominator. The known side will in turn be the denominator or the numerator. Write an equation setting the function value of the known angle equal to the ratio of the corresponding sides. Using the value of the trigonometric function and the known side length, solve the missing side length. All right, let's take a look. All right. Looking at this question real quick, is something else I want to show you guys real quick. Y'all probably remember this from high school, right? Yeah, this is the Pythagorean theorem right here, right? I'm not gonna lie, I don't know how to spell Pythagoras, right? It starts with a P. Pythag something. Pythagorean theorem, right? Theorem, right? Pythagorean theorem. That being said, right, here's the formula for the Pythagorean theorem. A squared plus B squared equals C squared, right? Here's what it means, right? Here's what it means. If I have a right triangle, like so, right? And I'm gonna actually name this triangle. So you know what, let me give it a little bit of space. Give it a little bit of space, right? I want to name this right triangle, right? I'm gonna call this triangle A, B, C, right? Let's name this triangle right here. This triangle ABC, right? Opposite angle A is leg A. Opposite angle B is leg B. And your hypotenuse always is C. All right? This is just a general drawing, but one that you should know. ABC is just a name.
Makes it a little confusing.
Right? Yeah. Always just keep it as ABC. Keep it simple, right? Opposite angle A is leg A, opposite angle B, leg B, opposite angle C, right, which is 90 degrees, is the hypotenuse, right? And it corresponds to the Pythagorean theorem, which is A squared plus B squared equals C squared, right? When do I use the Pythagorean theorem? I use the Pythagorean theorem when I know two legs and I want to know what the third leg is, right? When I know two legs and I want to know what the third leg is. So for example, if I know what A is and I know what b is, I can plug it in over here to the a squared plus b squared, and I can solve for c, right? It's that simple. And the same thing vice versa, right? Like if I know what c is, and I know what b is, but I don't know what a is, right? I can just subtract the b squared from the c squared and get a, right? Same old, same old, same old. Go ahead. Mm-hmm. Yeah. Uh-huh. You have to square root it. I'll give you an example. Give you an example, right? Let's say, for example, that a is equal to 3 and b is equal to 4, right? I want to know what is c, right? You start off with the formula a squared plus b squared is equal to c squared, right? You just plug it in, right? A is 3 squared plus b is what, 4 squared? And I don't know what c squared is, right? Do the math. This is 9 plus 16 is equal to c squared. 9 plus 16, what's that, 25? Is equal to c squared. But that's not c. I got to square root the c to get c by itself. But what you do to one side of the equation, you do the other side of the equation, right? So when you do that, what you got? You have 5 is equal to c. So now I know that c is equal to 5. That's how you do it, right? And I could flip it, reverse it, any which way. You know, I could say I know what C is, but I don't know what A or B is. Just subtract it, square root it, boom, that's your answer. All right? Well, let's look at an example. Let's look at this example right here. So over here, I want to find the unknown sides of the triangle, right? So I know what B is, and I know the angle, but I don't know what A and C is. So let's look at how we could do this, right? I'm just gonna redraw this triangle down here, or yeah, because it's kind of big right here. All right. I know that this is 30 degrees here. So what's this angle over here? Somebody tell me. 60. Very good, right? All right, so let's look at something real quick. I'm just straightening out this angle. I mean, this triangle that was given, right? This is 60, this is 30, this is 7, this is A, this is C, right? Now, okay, Microsoft, you ODM. All right. Now, we already know a special right triangle, right? We have a special right triangle already. Remember this one, 30, 60 degrees? Opposite the 30-degree angle is what? What number is opposite the smallest angle in the triangle? 1, right? And then the hypotenuse is always 2, and opposite the 60-degree angle is square root of 3, right? Hold up, I forgot something. I feel like Microsoft messed me up, but I feel like I wrote this before earlier. This is 7, right? Yeah, this is 7, and I'm looking for A and I'm looking for C, right? So this is not so bad, right? I can actually do ratios here to find one of the other angles. I mean, one of the other legs, excuse me, right? So for example, I'm gonna do a ratio real quick. I'm trying to pick a color. All right, let's say that I want to solve for C, right? I'm gonna solve for C. I know that, let's say angle B, which is 7, is to C in this triangle, as in this triangle, right? 1 is to 2. Did I lose anybody? Or does this make sense? All right. Makes sense, right? 7 over C is equal to 1 over 2. What am I gonna do after that? Just cross multiply. Real simple. Cross multiply, right? 1 times C is equal to 7 times 2. So C is equal to 14. Look at that, boom. So now that I know that C is 14, Pythagorean theorem. Not bad, right? So A squared plus B squared equals C squared, right? Now I don't know what A is. Right, but I know what B is, right? This is 7 squared. It's equal to 14 squared, right? Just do the math on that. Nothing. A squared plus 49 is equal to, I don't even know what that is. I'm not gonna lie to you. 14 squared, what's that? 196? Just watch your back, you'll get it. Now I'm gonna subtract 49 from over here. What I do to one side, do to the other. And then we good to go. A squared is equal to? All right. This is gonna be what? 196 minus 49, 147. And then after that, you just square root it. So A is equal to square root of 147. And that's it.
Oh, that's the answer.
Mhm. Yeah. Unless it could be simplified. Go ahead.
Oh,
Uh-huh.
Or C.
I did. Oh, you mean square root it? I did, yeah. See? Square root, yeah. Then they cancel out, so you get 5 is equal to C. Yeah. So in this one, right here, so we found the other two side lengths. That's probably the hardest question for tomorrow, finding the two side lengths. So the first thing you do a little ratio. This is to this as that is to that. Solve for one side, and then A squared, B squared, C squared. Go ahead. Yeah.
You want test scores?
I could do it tomorrow if you want. I could do it tonight too, but you'd have to give me a few minutes.
you all the way out to get both of them?
Both of them? Let me see. That's gonna be mad small. Yeah. I mean, this one is one of them. And if you want the other one, I could scroll up here. That's with the instructions and everything. Huh? I don't know. Yeah. Yeah. So would y'all rather y'all test give it back test 2? Would y'all want it tonight or y'all want it tomorrow?
You didn't finish with it, though, right?
I got one more left to grade. I could give it to y'all tonight, but y'all gonna have to wait a little bit. Tomorrow? All right. All right. Just give me a few minutes.
Wait, you got one square.
Yeah. And that's it. I don't remember the name.
Yeah, like you.
I don't remember the name. Yeah, yeah. Oh yeah. All right. Yeah, if you want to wait till tomorrow, that's fine. Y'all could go. Yeah. Just practice it, man. You got the homework, just look at it.
Practice it.
Are we putting
Yeah.
most of that on the system?
Mm-hmm. The only thing I didn't get to is like the word problem, but we'll talk about that tomorrow. Yeah. Yeah. Huh? Yeah. One. Yeah, this one.
This one?
Yeah. More work for you is more work for me. I don't know. Yeah. So I'm gonna give you a quadratic equation, and I'm gonna ask you for the answer, but I'm not telling you how to do it.
Yeah.
So whatever you want to do, just give me the answer. That's all I want. Yeah. Yeah. So like for the quadratics, you'll probably get like one question. And like I just want just give me the answer. Like I'm not looking for anything like special, anything like if you want to complete the square, cool. If you want to quadratic formula it, cool. You know, if you want to factor it and give cool, whatever works for you. Yeah. I see, man. Right. All three of them said equal to 0. Standard form, boom, boom, that's it. Yeah, all of them. And then radicals. All right. Most of the test is radicals. Y'all should really be studying that. So from chapter 8 down, right? Chapter 8 down. You know? Y'all have all y'all homework now. I'm not posting no more homework for the rest of our time. Yep, the last homework is today. Yeah, it is. It's posted. Yeah. Yeah. But that's it. That's the last homework for huh?
Yeah, it's 2.
Yeah, it's just 2. That's it.
It's 4 questions. It's more than 4 questions.
Yeah.
It's like,
Yeah. I mean, you can knock it out right now if you want. And I made a mistake and did like half of the questions in class today, but that's another thing. Yeah. Chapter 8 down. Yeah, so for homework tonight, y'all should focus on finishing from chapter 8 down to like whatever was posted today. And that's your test. Anything that's older that you didn't finish, like do that like next week or whatever, or this weekend, preferably this weekend. Right. Yeah, that's tomorrow's test. Yeah. Yeah. Huh? Yeah. Just focus on 8.1 going down. Yeah, those included. Yeah. But if you look at it though, like most of it was done already for today. Like it's literally like, yo, what sine of 30 degrees? But you already got the triangle, so it's like, yeah. That's like the whole homework. Tomorrow I'll do like the word questions, then right before the test, so y'all don't gotta worry. Yeah. Like physics questions, like if I have a ladder and I'm putting it on a building, what like how long of a ladder do I need and all that stuff. Fun stuff. All right. All right. All right. Definitely, yeah. So wait, is everybody done copying? Can I take this down? You good? All right. So everybody on the recording, have a good night. See y'all tomorrow. Tomorrow's the test. Yeah.